In order to demonstrate Ampere's law, here I built a simple electromagnetic motor. Here I'm proving that when I connect the two terminals, the circuit is closed, and due to the batteries, a current will flow through the batteries and through the ring. This ring is made out of copper, so according to Ampere's law, when a current flows through this wire, it generates a magnetic field. Because the wire has some enamel covering it, I had to take it away from both sides of the wire, so when I put it over the two batteries, then it will allow the current to flow through the ring. According to the right-hand rule, we know that the current that flows to the right will have the direction first toward us and then down, and the current that flows to the left will generate exactly the magnetic field that is opposite to the first one. So when both magnetic fields of both sides of the current interact with the magnetic field that is static, then one side will be pushed and one side will be pulled, and this will allow the ring to start rotating around its main axis. Because we want that the ring has an angular movement, we must take away only half of the enamel that is on the ends of the wire, so the current won't flow constant but intermittently, and then this will generate that sometimes the magnetic field that is generated through the ring will be pulled and pushed, and sometimes it won't. So this will allow the magnetic field to be intermittent also, and this will end in the angular movement of the ring. Also, as we increase the number of turns to form the ring, the intensity of the magnetic field will increase because we are creating more paths that the current will follow, and as it flows, then more current will flow and the intensity of the magnetic field will be stronger because there will be more linear current that will follow this right-hand rule, and then all the intensity will add up, and the intensity of the magnetic field, the final intensity, will be greater than if we use only one turn. To demonstrate Faraday's law, we see that if we induce a magnetic field that changes with time, then it will generate a current through the wire. Using the same principle of the ring as previously, we will see that if we move the magnetic field with respect to the wire or the wire with respect to the magnetic field, the effect is same, and this is because of Faraday's law.